Hello guys. Okay, this isn't extra work. It's just going over the actual hire paper with you. So I've got to say, before you even started, well done to everyone that got to this stage. Okay, the fact that you were able to complete to such a high standard and then being able to take the higher paper, even beginning it before you even open the paper, well done to everyone. Okay, so I did say I was just waiting for some extra papers before I release this video, but because it's the end of the week, obviously I'm just going to release all the answers and how to go through them. Obviously, a couple of you got pretty high, so well done to you. You'll probably be teaching me a few new things, sorry. Everyone else, I'll just go through it question by question. If you got it right, obviously don't worry about it, skip it. If you didn't, maybe just check to see if you knew it or not, because I have a feeling quite a lot of you could have done more than you actually did in the learning review. It might have just been because you just like froze up or you didn't give yourself enough time. Maybe you just make sure you're calm before you sit down and do the learning review. So let's get started. Okay, so they're just asking for equivalent. So you just need to make sure that you find out what is equivalent and what isn't. Okay, so in my mind, what I would have done is I would have just written all the expressions that all of these became like underneath or something, just so I can easily match everything up. So if I just run through all the different expressions, I'm not going to actually write out the original because you've got it right there. I'm just going to put them in the same placement. So it'll be a 3 by 3. So we've got 2a plus 8. We've got 3a take away 12. I am just literally simplifying all of them because if I simplify all of them, then that means that I can match them up very, very easily. Okay, and I'm not going through the process of how to do it for each of them because essentially all of you should know how to do it by now. So if you're having problems with this, you wouldn't have been sitting the higher paper in the first place. Okay, so looking at this, do I have any matches? Well, yeah, that one, they match up. Do I have any others? Well, this one matches up. And then last but not least, oh, I'm red. I'm writing in red. Why am I writing in red? Good knows. That one and that one match up. So those would have been your pairs. So I'm just going to put A, B, just in case the colours are not very clear. Okay, so you got pair A, pair B, pair C, and those are the ones that I would have written down. If you'd written down all of these and this was your working, because that's the way I would have done it, if an examiner was seeing it, they would have seen you match them up. But obviously quite a lot of you are writing down the original terms and that is the official way you should be doing it. Okay, this is just working, so just writing down all the answers. Next question. Okay, so question 2. They give you y equals 12 plus 2x. Okay, you should remember the equation that I've given where this is your gradient and this is your y-intercept. Okay, I could rewrite this equation to say y equals c plus mx. That doesn't mean c is now my gradient, m is still my gradient. Whatever is connected to your x term, that is your gradient, okay? So in a straight line graph, whatever is connected to this x term, that is your gradient. So in this case, what's connected to the x term is this 2, so m equals 2. Okay, so nice and easy there. So next part says which of these are linear. So you've got y equals 2x squared, you've got y equals half x, you've got y equals 12 take away x, and you've got y equals x squared take away 3. Okay, some of you might remember that I did kind of just briefly introduce quadratics to those people that were finishing in class. So you may notice that this is mx. There is no power there. As soon as you start getting a power, that starts making it into a completely different equation and line. So when you have a straight line graphs, I'll just briefly do it. So when I have a straight line graph, it's just literally a straight line. This is y equals mx plus c. But if I was to do a quadratic, it could look like that. This would be, I don't know, x squared plus 4 or something. Let's just say that's x squared plus 4. And then you have other graphs where they are cubic. So that would be cubic. That would have an x cubed term in it. Okay, and then if anyone is getting the pattern, you can start having curves. This would be a quartic, so it would have a quartic term in it. Okay, you can reflect them in the x-axis, but you will learn more about that when you actually start graphing nonlinear functions. But this needs to stay. So this power must be a power of 1. There cannot be a power greater than x to the power of 1. So going back to this one, the only ones that it could possibly be is this one and this one. Some of you are only circling one answer. Just because it is a 1-mark question does not mean there is only one answer. There was a clue in the actual question. It said circle your answers. Just make sure you are doing that, because all of you can do it when you're thinking about it. You just need to make sure you actually do it. Okay, next question. Okay, so question number 3 was talking about this actual sequence. So they give it to you in number form, but they also give it to you in pictorial form. You should be able to recognize both of them. It's the same way I was talking about the triangular sequence, where you had 1, and then you had this, and then you had this. So this is pictorial, but if I was writing it down, then obviously I would write it down in that form. Does that make sense? So it's doing exactly the same thing. It just has a pictorial and it actually has a number sequence as well. So if I just look at those dots, obviously a lot of you should have just been able to recognize that there were 7 dots that filling out that box, because there was 1, 2, 3, 1, 2, 3, 1. Okay. And then this said 10. You should have picked up on the pattern that it was 3 and then 1, and then it just kept adding a column of 3, and you had to draw the correct pattern. So if you only had 10 dots, that didn't actually justify you knowing what the pattern's about. So you just have that dot, and then all you have to do is just keep adding 3 dots in columns each time. So I've got the 1 dot, 3, 4, 7, 10. I've now reached the 10. That would have been the end of it, okay? So that's completing the table. You had to have both of them correct in order to obtain that mark. If one of them was correct and the other one wasn't, you don't. If you put 10 dots in an erratic fashion, which made absolutely no sense, you didn't get the mark. It had to look like this picture. Okay, I know some of you did it digitally, but unless I could see something that represented a pattern, I could not give you that mark. Okay, so find an expression for the nth term of the sequence, especially you guys. I've noticed that you guys usually just work with actual number sequences more than these pictures. So if I was just to use the 4, 7, 10, 13, you know the wonderful thing, which is first term, which is 4 plus n minus 1, and then d, which is our plus 3 each time. Okay, so we've been 4 plus 3n, take away 3, which is then 3n plus 1. Okay, so your first term was 4, your common difference was 3, and then you just have the n minus 1, expand the term, simplify it. If you had just given me this, I still would have given you the mark, because it didn't say find the simplified expression, it literally said find the expression. Okay, so in regards to the last part of question 3, it did give you numbers 1, blank, 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 6 to 5. Okay, so you know that it says it is 2 times the thing by 5. So it was relatively easy to do. So you just had 5, 25, 1, 2, 5. And if you learnt your square and your cube numbers, these two would have been very easy. Okay, even if you didn't know that 125 times 5 is 625, you should have been able to get 5, 25, and 125. They literally told you what you needed to do. And it said show your calculations below, so if I couldn't see any kind of working out, you wouldn't have got the mark for that. Okay, so for question 4, question 4 states 4 to the power of 0 plus 64 to the power of a half. Okay, so some of you did recognize the half, some of you didn't. I know when it was one of the questions during a lesson, and I kind of briefly wrote it on the board, so if you wrote a note on it, you knew about it. If you didn't, then you maybe wouldn't have. Okay, so you have 4 to the power of 0. Anything to the power of 0 is always 1. Okay, and then you've got 64 to the power of a half. So I'm just going to briefly go over this. So if I'm saying 8 squared, then that must mean it's 64, right? It's the same if I said 4 squared. That must be 16. And so on and so forth. I can kind of use 5 squared as well. But when we kind of start talking about what's the opposite to that, so rather than saying, oh, to the power of 2 is squaring, what is the opposite to that? So what you do with this power is you just find the reciprocal. So in this case, I would say, well, instead of the square, I'm going to say 64 to the power of a half is 8. I'm going to say 16 to the power of a half is 4. I'm going to say 25 to the power of a half equals 5. You can do the same with cube numbers as well. So if I said 5 cubed is 125, then I know 125 to the power of a third is 5, because we're finding the reciprocal, and the reciprocal of 3 is a third, the reciprocal of 2 is a half. So all you have to do just to get to the opposite is just find the reciprocal of whatever that power is. And that's what you should have done. So I've actually listed it as one of the examples. It is the square root of 64 is 8. Okay, the only query I had about this one is that the square root of 64, there are actually 2 answers. You're not expected to know it right now, so if you only came up with a positive answer, you did receive everything. But you guys are already aware a negative times a negative is also a positive. So personally, I would say just remember, especially as you're more challenging thinkers, you need to remember there are actually 2 answers. So right now, the positive answers are usually taken into consideration. Or if you're talking about geometry, you wouldn't really say, oh, that square has a side of -8, because that would just be ridiculous. Okay, so when you kind of think about it in those terms, yes, you would only choose a positive. Or if they give you limits, you would talk about the positives. But you will soon be introduced to the positives and the negatives when you kind of come into the GCSEs, and where it should have 2 roots rather than just having the 1. Okay, just making you aware of that. That's just a little bit of a side note rather than anything else. But you should be aware that negative numbers have 2 roots. Oh, last but not least, which I kind of nearly forgot. Write 4 to the power of 5 times to the power of 6. Okay, so quite a few of you just recognize the rule, so that just means it's 4 to the power of 30. A few of you, I don't know whether you read that properly or not, and so I think 1 or 2 of you put 5 to the power of 5, and then you accidentally put 4 to the power of 25, which it wasn't. I'm so sorry. It is 5 times 6 instead. If you need to know the rationale behind it, it's just I am doing 4 to the power of 5, and I'm going to do it 6 times. So I've got to go 4 to the power of 5, 4 to the power of 5, 1, 2, 3, 4, 5, 6. Okay, and we all know that we would add these powers together. So I've got 5, 10, 15, 20, 25, 30. So that is 4 to the power of 30. Okay, this is the long-winded way of just writing out this rule. Okay, so this one, it's a graph that shows a relationship between miles and kilometers. This is actually just, it's called a conversion graph. So you should just be able to convert as needs be. So it's saying what's the gradient of the line. We all know that gradient, so when we were talking about the gradient, and I remember doing this as part of your ratio, we were saying, well, the gradient is, if I move 1 across here, this is my gradient. Right, so if I got it down to 1, then that would be my gradient. So if this was 15, then this is only the gradient. I can find the gradient by finding out whatever this height is and dividing it by this 15, because I need to get back to that 1. Does that make sense? So that's what you kind of covered during ratio. But with gradient, some people would also just say it is change in y over change in x. Okay, so that's what you'll start learning when you do straight line graphs next year as well. So you've got change in y over change in x, which is the same thing. They're just teaching it in a slightly different way. So you are all aware that the gradient is for every x I go across, how much do I go up or down? If I go up, obviously it's a positive gradient. If I go down, then it is a negative gradient. And all they're doing is just bringing you a rule. So it'll be change in y over change in x, which is exactly what I said here. That's my change in y, that is my change in x. So it's exactly the same thing. So when you do this next year, huzzah! So my change in y is just go by these coordinates. Just looking at what they've done with this graph, they've given me a coordinate of 15 and 24. And you should know by coordinates that this is my x and this is my y, right? So y is how high I go. So if I was to draw this as a triangle, it would be 24 high, it would be 15 across. Just going back to what I've got here, that means it's 24 over 15, which worked out to be 1.6. Yeah? And that should be fine. Between miles. Oh, sorry, this is miles. This is kilometers. Okay, so I've got 1.6. So I'm saying if I wanted to convert between miles and kilometers, I would take miles and you would multiply them by 1.6. So when I have 40 miles, okay, all I have to do is multiply it by that 1.6, and I cannot remember what the answer is. So, gonna have to solve it. 64. 64 kilometers. Okay, some of you may already know the conversion between miles and kilometers. It's quite a well-known conversion, which is 5 miles to 8 kilometers, which is where a lot of people get this 1 mile equals 1.6 kilometers. It's actually quite a well-known conversion anyway. But you would have had to put 64 kilometers. You should have noticed from here that there are less miles than there are kilometers, so I would expect the number to go up. I would not expect it to go down. So for anyone that made the number go down, you just sometimes just use common sense. You all have it. So you should have been able to solve that one. But it's all good. Okay, next question. So question number 6, standard form, super easy. So you've got 0.3 and you've got 0.03. It's just a very easy conversion, so that one is more. And then on this side, it's 0.5. And what is a half but 0.5? This one was equals. Okay, just moving on to the next one. Okay, number 7. Okay, still it's the ratio. You did learn about the equation of a circumference where we say a circumference is pi d. You should remember that from your ratio work that you did earlier this year. Okay, so it does say the diameter of a wheel is 38.1, and it says use pi equals 3 to estimate. As soon as they said estimate, you should have started thinking about your work where you have to estimate all the time. So if I'm saying pi equals 3, what do you think I'm going to do with this diameter? They're telling me that it's 38.1, but they've told me to estimate, so I don't actually need to work out any exact values. I need to make it into 40, yeah? So then I would say 3 times 40, so the circumference is roughly 120 centimeters. Does that make sense? Because they said estimate, you couldn't get anything from finding the exact answer. Quite a few of you found the exact answer. No. I mean, one person even went into pi. I felt so sorry for you. Because it said estimate, you had to estimate. That was the key to this question. Do what they ask you to do. Don't just randomly do whatever you feel is best. If they're asking for an estimate, provide an estimate. If someone asked you for, I don't know, tea and you gave them coffee, that's not what they asked for. So please just ensure you always answer the actual question, because you're all very hardworking, and I know you can do these things. So we just need to make sure we double check when we are going through this to ensure that you are actually reading the question and then answering what they give you. Okay. Then last but not least, it said complete. Okay, I think a few of you got a little bit confused with the conversion part, but let's just say I have a square that is 1 centimeters all around. And then if I chose the equivalent square, but I put it in millimeters, that would be 10 millimeters, okay? That's just one side. That's not the actual area. When I think about the area would be 1 times 1, which is 1 centimeters squared, right? This would be 10 times 10, which is 100 millimeters squared. So, therefore, 1 centimeter squared, I don't know what this red mark is for, but it's starting to annoy me, I'm so sorry. So 1 centimeter squared is equivalent to 100 millimeters squared. That makes sense? So when you're looking at stuff and they're giving you areas or they're giving you volume, so if it was volume, I would have expected you to draw a cube if it made no sense to you. If you know the conversion, that's fine. If you don't, make sure you do something to help you out with that. I'm not expecting this entire paper to stay this way and only have complete answers. I expect to see your thought process, your working. No one is going to take this paper and go, yes, we must shred it, or it must remain as clean as possible. Just no, okay? The paper is yours. It's for you to be able to complete, and then you can reflect back on it, okay? So that's that one. Let's move on to number 8. Sorry, I was pausing. I'm just going to move on to pause right there. So you've got 8. Complete the statements. Okay, it's 3 marks, so yes, that's a mark each. But remember, this is a higher learning review, so you need to make sure you do put some work in. This is not just guesstimate your way through. Okay, please don't do that. £12 increased by a third. So a third of 12 equals 4. So 12 plus 4 is 16, right? And then it says £12 increased by a quarter. So 25% of 12 equals 3. 12 plus 3 equals 15. Okay, some of you might have been able to do that quite instinctively. So the first one would be this way. Because you kind of went, well, a third is bigger than a quarter. So obviously I know it's better. But if you weren't able to, I would have expected you to have shown some sort of working out. Okay, for the next one, it says 130 kilograms decreased by 30%. Okay, what's 30% of 13? Okay, I want to find 10% of this, which is 10% of, which is 13 kilos. Okay, so then I know that 30% is 39 kilos. 130, take away the 39, leaves me with 91 kilos, okay? So this is going to be less than 100 kilos. And last but not least, it was a half times a third. A half times a third, you just multiply the numerators, multiply the denominators, so then you would get 1 over 6. And then for the other side, just make sure if you divide by a fraction, you would multiply by its reciprocal. So you would have that, which equals 3 over 2, which means obviously 1.5 is bigger than a sixth. So that means that would have been that side. Okay, for number 9, they ask you to simplify. So get the numbers, multiply them together. So 6 times 2 is 12. A squared times a is a to the power of 3. That's the first one. The second one, 6 divided by 2 is 3. A squared divided by a is just a. Okay, so a bag contains some counters. You've got 5% of the counters are red, 35% of the counters are blue. The other counters are orange. There are 108 orange counters. How many counters are in the bag? Okay, so I already know 5 plus 35 equals 40. Okay, so 60% of counters are orange. Okay, so I know 60% and I've got 108. So just to make my life easier, I'm going to find out what 10% is. So I've got 108 divided by 6. Can't do anything with 1. 10, I've got 1, carry 4 across. 68. Sorry, why did I say 68? I'm so silly. I'm so sorry. So 48 divided by 6 is 8. Okay, so that's 18. So then if 10% is 18, that means 100% would be 180 counters. Does that make sense? Hope it does. Okay, so question number 11. It does actually tell you to complete the diagram at the top. So if you didn't complete the diagram, then obviously you didn't get the marks. These diagrams, we've done them numerous times in class, so I was a little confused by a couple of people not being able to do it, and then they just wrote the answer in the diagram, which is, well, the simplified answer for this into the diagram, which kind of made no sense for me. But, okay. The grid is super, super easy. It's just a multiplication grid. All of you can do them. So I've got A plus 7, and I've got A plus 5. 5 times A, 5A. A times A squared. A times 7, 7A. 5 times 7, 35. Okay? That's all I had to do to complete the diagram. Okay, and then in the next part, it says expand and simplify. I've already expanded it, so rather than going for a brand new technique, if you've already expanded it, all you have to do is collect those terms. So when I collect those terms, I've got A squared. These two share the same term, so I can collect them, which is 12A, and then I've got 35 as well. Okay. Okay, so in regards to the next question, so number 12 says Janet earns 48,000 a year after a 20% pay rise. So I'm saying 48,000 equals 120% because it's after, so it would have been 100 plus 20, which is 120%. Okay, she's not saying what did she earn before, so you're expecting a number less, but then you're also remembering the 120% rather than being 100% and then going down to 80. That wouldn't make any sense. You always start from 100. So if I'm at 120 and I want to get back, there are several different ways of doing this. Otherwise, you could just work out what 1/6 is, because if I had this, so say this is 120%. If I find out what 20% is, because all of them are 20% each, I've split it into 20%. If I find out what 20% is, I can just do 120, take away 20. Does that make sense? Okay. Alternatively, I could go back down to 20 or 10%, and then you can obviously find out from that. But because I've done this, I'm just going to do that now because it's not hard to do. So I'm saying divide it into 6 groups. That would be 8,000. 48,000, take away 8,000 would equal 40,000. Okay, if you'd gone down the 10% route, you still would have got to 40,000. Okay, and pounds, because they were talking about pounds. So whichever route you would have taken, you should have gotten to 40,000. If you didn't show any kind of clear, concise working, I couldn't have given you any kind of methodology. You needed to ensure it was a technique that worked. There are several that do work. Just make sure you choose one of them. Okay, so totally love this question, but hey, I love my geometry. This one would have been, there is a square of side 2a and an equilateral triangle of side 1a plus 1. The perimeter of the square is greater than the perimeter of the triangle. Okay, so this is one of those nice ones that actually sets you up for an equation. It didn't really tell you to set it up all in one go. It did actually break it down for you. So they made the question really, really nice the way they actually broke it down for you. So it said, write an expression for the perimeter of the square. So if one side of the square is 2a, then that means the total perimeter is 8a, okay? And then for this triangle, if this is a plus 1, then the perimeter is just 3 lots of them. Okay, you could have written 3 open bracket a plus 1 or 3a plus 3. I wouldn't have minded which one it was. Okay, so that's the expression for the square, the perimeter of the square, and the perimeter of the triangle. Then it said work out the range of possible values. They've already told you in the question up here that the perimeter of the square is greater. So you need to take this and make sure it's greater than this. So I would have said 8a is more than 3a plus 3. That's your first step, just making sure you set up that inequality, because it is an inequality, it's not an equation. Okay, and then you just do your normal take away 3a, which is 5a is more than 3, and then I'm just going to divide both sides by 5, which leaves me with a is more than 3 over 5. Some of you put 0.6, that's perfectly fine. but it's just more than 3 over 5. I could have left it like that. It's equivalent. That would have been A-okay. Okay, last but not least, this beautiful question about error intervals. So when you're talking about error intervals, you usually just think the first thing that comes in your mind is upper and lower bounds. So they're saying it's rounded to 1 decimal place. So I say, what is the value of 1 decimal place? This is 1 decimal place, okay? So I need to divide that by 2, 0.05. So in order to find out the upper bound, I'm going to take value and I'm going to add 0.05 to it. In order to find out the lower bound, I'm going to take the value and take away 0.05 from it. Okay, and that's what you literally pop in here. So I know the upper bound would be, let's just pop in that number up here. So it's 4.7. So 4.7 plus is 0.05 is 4.75. And then you've got 4.7 take away 0.05, which is 4.65. And you should recognize from these inequalities, obviously this one is saying I don't actually reach that, but anything below it will round to 4.7. And you're saying it could be 4.65, and anything that is that value or higher would be rounded to 4.7 as well. Okay, so that was the last part of those. I think a lot of you did quite a fantastic job on this, so I wouldn't worry too much. I just wanted to make sure you had a video that went through it, just to make sure that you kind of went, oh yeah, I forgot about that. Okay, and just keep it as a reminder. Obviously, when you are doing the higher papers, you need to remember it doesn't just talk about the topics that you are currently talking about. It will always bring in other stuff, and it will make sure that there is a bit of problem solving for you to actually figure out what you need to do. So those kind of questions are just setting you up for being able to approach those higher level questions later on in a nicer way. Well, more broken down way than it is for older years, but you'll get there. It'll be fabulous. Okay, so anyway, take care. Do have a nice weekend. Obviously, as I've said, this is not work. It's just going over your learning review, because I just wanted to make sure all of you had the feedback for it, because you spent the time doing it. So I do want to make sure that all of you did have feedback, regardless of whether the rest of the class did it or not. Okay, take care. Bye-bye.